Iridium is a chemical element with symbol Ir and atomic number 77. A very hard, brittle, silvery white transition metal of the platinum group, iridium is generally credited with being the second densest element, after osmium. It is also the most corrosion-resistant metal, even at temperatures as high as 2000 degrees Celsius. Although only certain molten salts and halogens are corrosive to solid iridium, finely divided iridium dust is much more reactive and can be flammable. Iridium was discovered in 1803 among insoluble impurities in natural platinum. Smithson Tennant, the primary discoverer, named iridium for the Greek goddess Iris, personification of the rainbow, because of the striking and diverse colors of its salts. Iridium is one of the rarest elements in Earth's crust, with annual production and consumption of only 3 tons. 191 Ir and 193 Ir are the only two naturally occurring isotopes of iridium, as well as the only stable isotopes. The latter is the more abundant of the two. The most important iridium compounds in use are the salts and acids it forms with chlorine. Though iridium also forms a number of organometallic compounds used in industrial catalysis and in research. Iridium metal is employed when high corrosion resistance at high temperatures is needed, as in high-performance spark plugs, crucibles for recrystallization of semiconductors at high temperatures, and electrodes for the production of chlorine in the chloralkali process. Iridium radioisotopes are used in some radioisotope thermoelectric generators. Iridium is found in meteorites with an abundance much higher than its average abundance in Earth's crust. For this reason, the unusually high abundance of iridium in the clay layer at the Cretaceous-Paleogene boundary gave rise to the Alvarez hypothesis that the impact of a massive extraterrestrial object caused the extinction of dinosaurs and many other species 66 million years ago. Similarly, an iridium anomaly in core samples from the Pacific Ocean suggested the Eltanin impact of about 2.5 million years ago. It is thought that the total amount of iridium in the planet Earth is much higher than that observed in crustal rocks. But as with other platinum group metals, the high density and tendency of iridium to bond with iron caused most iridium to descend below the crust when the planet was young and still molten.